For the first one, we have a quadratic function in the form of f of x equal to a times x minus r and x minus s is in what form? What form is this in, Olivia? Yeah, this is in factored form. Is in factored form, where r and s are considered to be my x-intercepts or zeros. So let's do an example in factored form. So if we have f of x is equal to x minus 3 and x plus 2, can someone tell me what my x-intercepts will be? What are they?
2, -2 in the A?
Nope.
Oh, +3.
Yeah. So my x-intercepts are when x is equal to -2 and x is equal to +3. The next one we have is a quadratic function in the form of f of x is equal to ax squared plus bx plus c is in what form? Standard. Okay, and like I said, standard form is only useful for finding your y-intercept. Okay, and remember the y-intercept is always going to be the last number that appears in the equation. And then the last one, a quadratic function in the form f of x is equal to a times x minus h squared plus k is in what form? Omer, this is vertex form. Where h and k are my vertex. So let's take my vertex form and let's see if you guys remember how to figure out the vertex. So if I have f of x is equal to 2 times x minus 3 squared plus 5, can someone tell me what my vertex is going to be? Brooklyn?
3 and 5.
Yep, 3 and 5.
Wait, sorry, how did you get that?
So my h is -3, but remember with anything in the bracket, it's always opposite of what it is. And then my k is going to be +5. So my vertex is 3 and 5. Pardon? It's first unit.
Okay.
Yeah, vertex form. Remember the reason why we change the sign is because we always set our bracket equal to 0. So when we have x minus 3 equal to 0, I move the -3 over and it becomes positive. So we have two functions here. We have one in standard form and one in vertex form. So we have f of x is equal to x squared minus 4x plus 1, and g of x is equal to x minus 2 squared minus 3. So I want you guys to take 2 to 3 minutes to complete those table of values. So remember for the first one, we have x is equal to 0. So wherever you see x, you're going to sub in the number, okay? So the first one will be, let's say f at 0, sub in x is for 0, so we have 0 squared, minus 4 times 0 plus 1. 0 squared is 0, -4 times 0 is 0, and then we're left with plus 1, which means f at 0 is 1, so my number over here is going to be 1. Yes, Cynthia?
Is there still the rule that whatever is the first is also the last, so first one?
No. Because remember that only happens when I have -2 here and 2 over here, right? So it has to be the negative of it. It doesn't have a pair with it this time. So you can't use that rule right now. So you have to sub in x for every single time.
Oh, okay.
So yeah, so take a couple minutes to complete that table of values. Can someone tell me the y values for f of x? Rebecca.
1, -2, -3, -2, and 1.
Perfect. So that's good. So, as you can see here, if you go to g of x, if I were to ask you to give me my vertex, what would my vertex for g of x be? Rita. 2 and -3, which means when x is 2, my y value is -3. So what do you notice between both of these table of values?
They both have the same vertex?
They both have the same vertex, which means my table of values are going to be the same, or are they going to be different?
The same.
The same. So f of x and g of x are the same, except what they did to g of x is they used f of x to complete the square and change it into vertex form. How many of you remember completing the square in grade 10? It's one of those. So going from standard to factored is easy. Going from factor to standard is easy. But for some reason, when we want to go from standard to vertex, some of you just get confused. Because there's some like weird multiplication you have to do. So yeah. So I'm going to try to explain it as slowly as possible.
Oh, wait, what you notice is the vertex.
So what do you notice about the two functions? They are the same. So if we plot them out, we're going to notice they get the same. So f of x we have is x squared minus 4x plus 1. So our first point is going to be 0 and 1. My next one is going to be 1 and -2. Then 2 and -3. And then after my axis of symmetry is where this is going to repeat. So my graph looks like this.
So we're plotting what we have.
We're just plotting the table of values we have. And our vertex form is going to be the same thing because it gave us the same table of values. Oh, we just used the points from here. You see our table of values? Yeah, I just use them as coordinates to plot. So my first point is 0, 1, which is right here. My next point is 1 and -2, which is down here. And then we just continued with the table of values. So now g of x is going to look exactly the same because it has the exact same table of values. So g of x is equal to x minus 2 squared minus 3. So again, same points, 0, 1, 2 and -2. I mean 1 and -2, sorry. Oops. That's an ugly graph. Mm-hmm. Why are my graphs so small? I'm trying to save paper. Well, you can't zoom in like I can with this guy. So.
That was very, very difficult.
I complete the square. Okay. So we are going to, so before we do that, we're going to complete this chart. So what was my vertex for those graphs? Olivia. Okay. What was my y-intercept? So if I go back to my graph, what is my y-intercept? 1. So 0, 1.
What if you don't put the 0, comma? Just put
It's a coordinate. You can just put y-intercept happens when a y value of 1. You can put that as well. Do I have any zeros? Yeah. So, because it's probably going to give me some sort of decimal, I'm just going to plot this on Desmos. So let's go to Desmos here, and I'll show you guys what the x-intercepts are. So I got y is equal to x to the power of 2. Is it minus 4x plus 1, right? Okay. So what are my x-intercepts? They're right there. Well, I got to move this over. What are my x-intercepts? Yep. 0.268 and 0. Yep. So, and then this is going to be the same. And what is my axis of symmetry? Oh, I just plotted it on Desmos. I just entered the equation. Yeah. And then what's my axis of symmetry, Ashton? X is equal to 2. That's where my graph splits in half. So the reason why I'm using Desmos right now is because you guys don't know the quadratic formula yet. And that's where you would find your x-intercepts if they're decimals, like very weird decimals. I'm not going to make you memorize it. I'll give it to you on when you do your assessments. I will provide it for you.
Everything that's with basically what's
So if we look where my graph crosses the x-axis, it happens at, let me see if I can find it, right here, 0, 1.
Oh.
Yep.
Well, I'm not like I should do the quadratic formula.
Yep.
It's not like x equals positive negative.
Negative b plus minus square root of b squared minus 4ac over 2a, yeah. That stuff.
These two are so ugly.
Okay. So what we want to do next is we want to expand our g of x, which is x minus 2 squared minus 3. So when I say expand, what does that mean? Olivia? Distribute. So if I have x minus 2 squared, how many of those brackets do I have? 2. So you can either do it the short way or the long way. Taught you guys the short way, I think. Some of you are like, this is confusing. So we have 2 of the same brackets. Minus 3. So you're going to forget about the minus 3 until the end. So remember, we're going to FOIL. So you're going to distribute. So can someone tell me what we get when I distribute, when I use the distributive property or foiling those two binomials together? Brooklyn.
X squared. Take away 2x.
Yep.
Take away 2x.
Mm-hmm.
And positive 4.
And then minus 3. So now we have to collect like terms. So my like terms are negative 2x and negative 2x, and positive 4 and minus 3. So x squared stays the same. What's negative 2x minus 2x? Negative 4x. And what's positive 4 minus 3? Great. So as you can see, when we expand our vertex form, it should give us back the original standard form. Yes?
Wait, how did you get -2 minus? Oh,
So when we go from vertex to standard, it should give us back our original standard form equation. Did you guys notice I put on unit 4, I put a sad face because another quadratic unit?
Where?
Oh, and on Google Classroom. Didn't you see? Yeah. So we went from vertex form to standard form.
Oh, wait, what? Oh, yeah.
So we're almost done. We just have a couple of things to do. You guys want to learn how to complete the square today or tomorrow? I mean, or not tomorrow, or Thursday.
Can we do it? Can we learn a little bit today?
I can teach you how to do it. I can teach you how to do it a bit today.
And then elaborate
Yeah.
on it.
Because I don't think this lesson teaches how to completely do it yet. So I want to fill in the chart for the next one. So sometimes we have factored form, sometimes we have standard form, and other times we're given the vertex form. So from vertex form, we can go to standard form and then factored form. From factored form, we can go to standard form. It'll be hard to get into vertex form with the factored form. And then in standard form, we can figure out our factored form and figure out our vertex form. So our first one we have it is in factored form. So how can we go back to standard? What do we need to do? Foil. So to go from factor to standard, I just have to foil. So who can tell me what my standard form is going to be? Jade?
X squared
Mm-hmm.
minus 5x.
Not minus 5x.
Or, sorry, plus 5x.
Plus 5x.
Minus 2x.
Yep.
Minus 10.
Yep. So now our like terms are always in the middle. So what does it simplify into? Positive 3x minus 10. So this is what we call my standard form. So from standard to factor, just FOIL. That's it. Now for the next one, we're starting with vertex form. So we need to convert that into standard form first before we can change it into factored. Yeah, so we expand. So my vertex form is y is equal to x minus 5 squared minus 36. So how would I be able to expand this? Brooklyn?
We could do x take away 5 times x take away 5.
Yep.
Take away 35.
36.
36, right?
Yep. So what's left when I FOIL? I'll zoom in a bit more.
It would become x squared and then negative 5x.
Okay.
And then negative 5x.
Perfect.
And then positive 25.
Minus 36. And then we just collect the like terms. So can someone else tell me what this simplifies into? Sarah, you have your hand up?
X squared minus 10x.
Okay.
And then minus 36.
What?
11.
Yeah, minus 11. Yeah, perfect. So that would be my standard form. Okay. Now I can take my standard form and convert it into factored form. So basically what we have is our trinomial. And how do we factor trinomials? Product and sum. So what's my product here? Jade? Okay, what's my sum? Negative 10. So I need two numbers that multiply to negative 11 and add up to negative 10. Can someone tell me? Emma?
They have to add up to positive negative 11,
Yep.
right?
That has to add up to negative 10 and multiply to negative 11.
Oh. 1 and 10. One and 10. But one of the other one is negative.
No, I'm talking about 10. Go up 1.
Oh, 11.
11 and 1. Okay, so which one's going to be negative, Emma? Nope.
It's the 11.
So negative 11 times 1 gives me negative 11, which is what we want. And negative 11 plus 1 gives me negative 10. Perfect. So we have no number in front of my x squared, so I can immediately write my factored form with its brackets. So what would this look like fully factored? Brooklyn.
X take away 11 plus 1.
Yep. Perfect. So that would be your factored form. So for my last example, I have it in standard form, and I'm going to change it into factored form, but we're not going to do vertex form just yet. The reason why is because I don't want to deal with the odd numbers in the middle, because you have to divide by 2, but I'll explain after. So how can I change my standard form of y is equal to x squared plus 3x minus 10 into a factored equation?
Product is down.
Okay, Ashton?
Equals x plus 5, x minus 2.
Yep. So 5 times negative 2 is negative 10. And 5 plus negative 2 gives me 3. So Ashton got y is equal to x plus 5 and x minus 2. Okay. Everyone good with that? It's basically review at this point. Okay, so do you want me to show you how to change this into vertex form? Just like briefly, and then tomorrow we'll like have a brief lesson or a more, no, not tomorrow, on Thursday. Because we're in the CAF tomorrow, because they're doing the whiteboard things here. We're gonna, yeah.
What about the OSM?
Show how to change the example y is equal to x squared minus 10x minus 11 into vertex form. So listen carefully. So when we want to change from standard to vertex form, I'm going to focus on these two terms first. Okay? Just focus on the first two terms. So you're going to box off x squared minus 10x. So start with that. So what's going to happen here, okay, girls, please, trying to explain. So this x squared is going to change into an x, okay? You're just going to basically square root it. What you're going to do with this guy over here is you're going to take that negative 10. So this negative stays here because it's the same sign. You're going to take that 10 and divide it by 2. So what's 10 divided by 2? 5. So your bracket is going to be x minus 5 squared. Okay? On the outside of your bracket, so all you're doing is taking this and dividing it by 2, and that's how you get the 5. What you're going to have outside of the bracket is a minus. And what did we get when we took 5 and divided it by 2? I mean, took 10 and divided it by 2. What did we get? Yeah. So we're going to have a 5 in a bracket, and that's going to be squared, hence completing the square. And then you're going to keep the minus 11. So this stays the same. So x minus 5 squared stays the same. We know 5 squared is minus, when we square that, it's 25. So I get minus 25 minus 11. So what happens when we take negative 25 and subtract 11? What do we get? Negative 36.
Wait, how did you get negative 25?
So we have this minus out here,
Yeah.
okay? And then in brackets, you're going to put the number we got when we divided 10 by 2, which is 5, and you have to square that because it's completing the square. So there's a longer way to do it, but this is the shorter way. The longer way involves this right here. So once you square that, you're going to get negative 25 minus 11, which gives you minus 36. And if we look up here, our vertex form was y is equal to x minus 5 squared minus 36. Okay. I'll give you a different example. It works with everything. Okay, so our next example we have is y is equal to x squared plus 4x minus 6. So again, we're going to box off the first two terms. What is my bracket going to have, Emma?
X plus 2
Okay, and what's going to be on top of my bracket?
squared.
A squared. And then remember that minus comes outside of the bracket. So what did we get when we took 4 and divided it by 2? What was 4 divided by 2? 2. Okay. So what's 2 to the power of 2? 4. So you're going to get minus 4 minus 6. So what is my vertex equation going to look like now? What's negative 4 minus 6? Negative 10. So that's my vertex form. Y is equal to x plus 2 squared minus 10. Yes, Rita? Because when we square a number, correct? If, say, I have the number 2, if I square positive 2, it's going to give me 2. If I square negative 2, it's going to give me, if I square positive 2, it's going to be 4. Negative 2 squared is also going to give me 4. So you need both signs to be squared, hence completing the square. I'll show you the long way, but I don't know if that's going to confuse you more.
I'm not going to say that's very confusing. Because I actually kind of understand this.
Okay. So I'll show you the long way.
No, wait.
Unless my sons are actually.
Yeah.
I'll show you the longer way. Yep.
Is it always a negative after the bracket?
It's always a negative after the bracket.
Oh, even if
It just goes up really, really quick.
sorry, are we gonna have to know the long way or no?
No.
So wait, even in this case, like, are we gonna have questions with the positive or we just have to make it a negative? Or
You're
oh, okay.
Yeah, completing the square is one of the weird ones that takes time to figure out. So try to not burn out your brains with this right now.
Yeah, I've been ignoring it.
Okay. So the last example we have is the graph shows us the flights of a paper airplane where time t is in seconds and height h of t is in meters. I want to use the graph to determine an algebraic model in vertex form. So we know my vertex form is y is equal to a. Well, using a graph, it's easy. So if we look at this graph, what is my vertex? What's my vertex when looking at this graph? That 1.5 and 10. So which one is h and which one is k? Olivia? So when I put h back into my bracket, is it going to be x minus 1.5 or x plus 1.5? Yeah. So when you always put it back in the bracket, you're just switching the sign again. And what's my k?
So how do we find our H and our K?
With the vertex.
So with the vertex, so our H is gonna be
The first number.
X value?
Yep. So h is your x value and k is your y value. So far I have y is equal to a times x minus 1.5 squared plus 10. I don't know what a is. So what do I need to use from this graph to help me figure out what a is going to be? Sarah? We're going to use the point. So what point is given to us on this graph? Ashton? Nope, there's another point given on this graph. Cynthia? Nope, we have another one given. It's literally labeled on there. Olivia? Yeah, what's the point that we can use to solve for A? Yep.
Wait, why did we take that? Why did you give us that number?
It's because we need to figure out what A is.
Does that give us any like?
Yeah, because do you realistically know what this is?
No.
No.
So you gave us that one because it's more obvious?
Yeah. Well, you can also use this one too. You can use 2 and 8.8 if you really wanted to.
Does it matter what we use? Can we use like any?
Preferably the one that's given to you is the easiest one to use because you know that value is true. So far I have y is equal to a times x minus 1.5 squared plus 10. So how am I going to use 1 and 8.75 to figure out my a value? Olivia? Yep. Perfect. So I get 8.75 is equal to a times 1 minus 1.5 squared plus 10. So we're going to simplify our bracket first. So what's 1 minus 1.5? Pardon? Negative 0.5 squared plus 10.
Wait, sorry, so I'm putting the coordinates into the.
Yep, so x is 1 and y is 8.75.
Got it.
Okay. So who can tell me how I can solve for a? Olivia.
You move 8.75 to the other side and move A to the other side.
Oh, so you want to do it that way?
Oh.
No, I mean, you can keep a on the right side, but if you want to move stuff over, that's fine.
Okay. Is that correct?
Yeah, but remember a negative number squared is going to give you positive. So a is going to be positive on the right side anyways.
Okay, and then after that we solve for A.
Yeah. So we can move the 10 over to my left side to move this guy over. So it becomes 8.75 minus 10. And what's negative 0.5 squared? If you were to square that number.
Wait, why are we squaring that number?
Because it's negative 0.5 squared. So I got 0.25a. So now what's 8.75 minus 10? Yes, Olivia? Yep.
You can't move the A since it's multiplication.
You would have to multiply it first and then you can move it after.
Oh, okay. But if you didn't do that and you didn't show your work, did you get marked?
If you moved it correctly, I would be fine. But if you messed up the signs, then I wouldn't mark it correct. So what's 8.75 minus 10? Sarah? Okay, and to isolate for A, what do I need to do?
Okay, how did you get?
Yes, Emma?
How did you get negative? 0.25a?
Because when you square a negative number in a bracket, it's positive. Okay, so what's negative 1.25 divided by 0.25? Negative 5. So therefore, y is equal to negative 5 times x minus 1.5 squared plus 10. So that would be your vertex form equation.
Oh.
So it's nothing new that you haven't done. We did the same thing when we had it in factored form and tried to figure out our a value. We used the points. Same with our standard form and everything of that matter. So you guys have around 20 minutes to do the practice work from the I have to upload that actually. I haven't uploaded it yet. So I'll upload the unit 4 homework. And that's what you'll do for the rest of class. And I'm going to mark the rest of the tests that I didn't mark.